This is HRW98P012. So it says a 1.5 kilogram snowball is fired from a cliff 13.5 meters high with an initial velocity of 14 meters per second, directed 41 degrees above the horizontal. Using energy techniques rather than the techniques of Chapter 4, find the speed of the snowball as it reaches the ground below the cliff. Chapter 4 being kinematics. So we're not going to use kinematics, which we could totally do, but we're not going to. Instead, we're going to use energy. So, here we go. I've just same relevant information. Okay, mass, the angle, the launch velocity, the height. Let's see. This is really part A. Well, I know that the total energy is not going to change. So let's find the total energy. When it launches, the energy, it has kinetic energy because it's launched, it's moving, and it has some potential energy too. Let's just call the ground, call that 0. Or I guess that should be a y. But anyways, well, the kinetic energy is 1/2 mv squared plus the potential energy is mgh. Now there's an m there. I'm just going to move that m out to the front. Okay, so that would leave me with 1/2. Well, the velocity was 14 meters per second. It doesn't matter what the angle was. It was moving 14 meters per second, therefore that was the velocity. Plus, now remember I pulled an m out, so all that's left is g and h. So g is 9.8, and this thing is 13.5 meters high. Okay. Alright, so plugging all that into a calculator, I get m times 230.3. Okay, now I could totally put the m in, but I'm leaving it out because, as you may have noticed in some of your other problems, when dealing with energy problems, oftentimes the mass cancels out in the end. And I have a feeling this one will too. Alright, so this is my total energy. That's not going to change, like ever. So when it hits the ground, it will still have exactly this much energy. Well, when it hits the ground, at the ground, also kinetic energy plus potential energy. But in this case, it's at the ground. So the height is 0. That means the potential energy is 0. So basically, the energy just equals the kinetic energy. Okay? So that equals m times 230.3. That's a parentheses. Okie dokie. Well, kinetic energy is 1/2 mv squared, so that equals m times 230.3. And see, just like I thought, the masses cancel out. I don't care about them anymore. So if I solve for v now, solving for v, see, I can do multiply both sides by 2. So I get v squared equals 460.6. Come on. So then v equals the square root of that, which is, calculator, 21.5 meters per second. All right, that was part A. Part B says, okay, what about if this is 41 degrees below the horizontal? So what if instead of kind of up, it was launched kind of down? Okay, theta. Well, if you go back and look at what we did, there were no angles involved. It was the launch velocity is what mattered. It didn't matter which way you threw it. So nothing would change. This is the same for A and B. Now C says, well, hang on, what if the snowball is bigger? It's 2.5 kilograms. Well, the mass canceled out. The mass ended up not carrying. It doesn't do anything. It doesn't affect the answer. So even if we did all this with a mass of 2.5, we would still get the same answer. So this is also the answer for C. So if we go back and look, yep, see A is 21.5, B is 21.5, and C is 21.5 meters per second. That's it.